And now let's look at a continuation of that, looking at it from a Cramer's rule. So we can have 3x minus 1 is equal to 8, and then x minus 2y is equal to 5. So in this case, a coefficient matrix can be equal to this: 3, negative 1, 1, negative 2, and then xy at this particular point is equal to 8, 5. So we remember this is A, matrix A is equal to 3, negative 1, 1, and negative 2. And I can be able to find A inverse for this, which is over 1 over det of A multiplied by adjoint of A, which is equal to this times that is equal to 6, negative 6, negative 6, negative negative 1. So if it is like that, then adjoint of that one is equal to negative 2, 3, 1, negative, and 1. Because I've multiplied by negative, so it has tended to be positive. So this gives us negative 6 plus 1, which is equal to negative 5. So it's equal to negative 5 multiplied by negative 2, 1, negative 1, and 3, which normally gives us a problem like this is 10, and the positive 10, negative 5, positive 5, and the negative 15. So this is actually the value. So you can actually see that in all scenario, the sum has a 5. So if you decide, you can be able to reduce it. All of it divide by 5, it can reduce, but you can just leave it like that. It doesn't matter. And when you do that, so this one, it is like an inverse of that, an A inverse. So if you multiply, now let's say this is an A inverse. Remember, if you multiply A multiplied by A inverse, you have got an I. Take note. So this is the approach that can be required. So in this case, in this solution now, for you to get the solution for this matrix, I want you to do the following. So you can be able to say x, y is equal to, you take the matrix which you had at the beginning. So you multiply matrix A inverse multiplied by multiplied by this particular matrix 8 and 5. But now you know that A inverse is equal to A over modulus of A adjoint of what? Adjoint of A multiplied by bracket 8 over 8 and 5. So when in that case, you can be able to say you can be able now to actually say on this one, you can actually say it's 1 over modulus of A. Then it means that you multiply out and get what is the value there. Negative 6, we got 5, and then you can multiply the inverse of that, negative 2, 3, negative 1, positive 1, and then you can multiply by 8 and 5. So first of all, you can multiply this by that, this by that, so that in the end you can multiply the result by the scalar, and then you can get the value of x and y. So I want you to practice this so that you can determine what could be the value for that particular statement. So can you get the value and then evaluate? So that's the way we can be able to do computation of that nature, looking at the different factors of interest which can be considered. Now, on the last section of this, Tim Akalan on the what is called a 3 by 3 connotation, where we can be able to find like a matrix which is given by A11 x1 and plus A12 x2 plus A13 x3 is equal to B1, and we've got A21 x1 plus A22 x2 plus A23 x3 is equal to C, and A31 x1 plus A32 x2 plus A33 x3 is equal to, this is B1, B2, and this is B3. This one, it can be represented as A11, A12, A13, A21, A22, A23, A31, A32, and A33. And it can be represented by x1, x2, and x3. And this is the same as B1, B2, B3. So this is actually the matrix equation. So from this particular equation, now you want to calculate the determinant of coefficient matrix A, which is equal to this one. So to get a coefficient matrix, to get a coefficient for this particular matrix, its determinant, we normally can be able to calculate that looking at the following. So it's like you take determinant of that particular statement, which is which can be equal to A11. Let me start on top there. Okay, so it can be A11 multiplied by the modulus of A22 and A23, A32, A33, and then you take A12 and you take the modulus of A21, A22, A23, sorry, and A31 and A33, and then you can be able now to take the final one, A13, which is A21, A22, and A31 and A32. So this is actually the way it goes. So this sign, the way it goes is that this particular sign, it's a positive value and it's a negative value, positive value, negative, positive, negative, positive, negative, positive. So that's why this is the first number, A11. It is now taking this one as a we call this one as a cofactor of A11. And if I want to take a cofactor of this value, the middle number, it is actually this one. That's the number with a negative sign there, here, negative. And its cofactor now, we actually look at what is remaining from that. So this is the value and that is the value, which is now A21 and A31 and A23 and this one. Whereby the last one, this one, it is this value, and then its cofactors, it is this part. Let me put a different color. It is this particular part. So that one is now A21, A22, A31, A33. So it is actually like that. So when you simplify this one as a determinant, this one as determinant, that one as a determinant, and multiply with those particular values and subtract, you actually get an identity matrix. You actually get a determinant. So that's what can be defined from a determinant point. So on that one, similarly, if you can recall, we were able to get the different solutions for a particular for a problem of this nature. So we can actually say, if we have got the solution x1 can actually be given by b1, b2, b3, and a12, a22, and a32, a13, a23, a33. And this one you can divide by the determinant of a11, a12, a13, and a21, a22, a23, a31, a32, a33. So you can get the determinant of that. So for x2, it means that you'll be able to substitute this by that, and then you maintain this in there. And for a3, you take this out, you bring in my b, and then you maintain the other one, so that it's like the way we are doing in the previous mathematics, so that at the end of the day, this is like a modulus of a, and then you adjust wherever the values are, so that if it is x2, you substitute only this part with abc, I mean with the b's. If x3, you substitute that one with the b's, so that in the process you are able to determine the value. So then we actually solve them in that particular process, so that at the end of the day, if you are given an expression, and if you are given an expression like the following, to say 2x1 plus 2x2 minus x3, and then you have got 4x1, and there is nothing there, and there is 2x3, and there is 6x2 minus 3x3 minus, like that, where I've got -3 there, and 8 and -12. So you can actually write them in a matrix form and determine the solution for such particular statement as follows. So in determining the formula, you can first of all represent them as matrix. So it can be -1, 4, 0, 2, 0, 6, and -3. So it can be x1, x2, x3, and then it can be -3, 8, and -12, and -12. So in that way, once you do that, you can actually say, so what is my x1? So my x1, you take determinant of -3, 8, and -12, 2, 0, 6, -1, 2, and -3. So you take a determinant of 2, 4, 0, 2, 0, 0, -1, 2, and -3. And then for x2, now you substitute the middle one. So you say 2, 4, 0, and then -3, 8, -12, and then -1, 2, and -3, and then you take modulus of 2, 4, 0, 2, 0, 0, -1, 2, and -3. And then you say x3, then you can take for this one, so it will be 2, 4, 0, 2, 0, 6, and then you take on the other part, you take -3, 8, -12, and then you take the following 2, 4, 0, 2, 0, 0, -1, 2, and -3. So this is actually how you actually can be able to work on the results. And then when you simplify them using the method of determinant, you can get the solution for that particular statement. So I want you to try and solve this one, so that we can establish how much could be the value. So when solving, make sure that x1 is equal to -12, x2 is equal to 12, and x3 is equal to, when solving, make sure that x1 is equal to half, and x2 is equal to negative half and x3 is equal to 3. So you should prove it as to that particular point. I thank you.